recording. So if you were here, I gave out a handout of all the ones that were missed the most on the practice test yesterday. I also want to point something out. I sent out a remind um, yesterday letting you know that the test results were posted. And this is going to happen with each test and practice test. Right? The reason why we went through that headache of having to sign into your school Google account is because that's the only way. Did you tell them already that you're in person? Oh, okay. Well, take one of each of those. Take one of each of those papers. Let's take a look. See. Nobody in the middle. Yeah. So let's see. Lana's here. Mohammed is here. No Daisy. Sam is here. Miranda's here. You are correct, Angel. You are in person. Mohammed, Lana. Okay. All right. So I sent out a remind yesterday that said that I had sent out your test results. That's the reason why I made you sign in with a Google. Because if you use any other email, it's not going to get back to you. So if anybody bother, and includes to those of you at home, if anybody check your school email to look at the results? Thanks, Gary. Keep on. You're awake? Hey, Diana joined us. Hi, Diana. Okay, so it won't. Yeah. You? No way. So it won't give you the right answers, but it'll at least show you which ones you got wrong. In addition to that, I posted on our e-class page, look, week 5, okay, content is where you find everything. So under week 5, under practice test, you see the results, okay? There's 3 columns. The first column shows the last 4 of your ID. If you don't see the last 4 the last 4 digits of your ID there, that means I didn't get a practice test from you. And that's going to be important, okay? The second column is the percentage that you actually got correct. Okay? So, what's that? Um, so like if you look at that real briefly, what was the best actual percentage that we had out of all the people that took it? Yeah, somebody got 72%. That was the highest amount. Okay? Then the last column is what you got with the curve. So I give you the highest of those two, choose the curve. Theoretically, a curve could hurt you. Like your curve score could theoretically be lower than your actual score, but hardly ever happens. And if it does, I give you the higher of the two. Okay. So as of right now, that's what you have. If you look in the grade book, you have whatever is next to the last 4 of your ID. But since this is a practice test, I allow you to practice. You can improve your grade. Okay. But how you do it will depend on whether or not you're here. If you are here and you have a qualifying score, meaning you turned it in and you have a score, you have until tomorrow night to go and retake this. If you look lower on the page, there is a retake. Practice test 1. Maybe I should. I don't know how to look up on here, but not where it says test. That's for Thursday. If you see practice test number 1 retake, if you took, as long as you took the test the first time in class, you can take it an unlimited times from now until tomorrow night at 11:59 p.m. I will take the highest of those scores from the retake. I will take your score here and average it. You get the average of the two. So, like for instance, and this is one of the benefits of taking it in class. How many people got 100? How many people out of all the ones that took it got 100 that would have heard? Looks like 3 people. Okay, those 3 people, they don't have to go back and retake it. You already got 100. If you want to for practice, good. I'm not going to take away your 100. I'm not going to lower your score. But you don't have to. If you're one of those people that have 100, you don't have to go and retake it. Okay? But now let's say you're this person that has a 60 here, and you went from a 38 to a 60. Well, you might want to improve a 60. A 60 is still not that good. And you're going to be retaking this after I go over it. Today I'm going to go over the ones that were missed the most. If you're here in person, I'll give you a handout so you can write on it. If not, you have to write on paper at home. And so now let's say you get 100 on the retake. You know, you retake it 3 times, you finally get 100, that's your highest score. What is the average of 160? You take 60 on 100 and you average it. What's the average of the two? It is 80. So you would end up with an 80. Okay? But now, either because you didn't show up, or I know some people have some computer issues, let's say you don't have a score here. Well, now you can only take it once. And it's for fairness. You're also taking it after I've given you a bunch of the answers. So, and that's not to say that your score should be any lower, but you're not going to get the benefit of a curve, and you can only take it once, not unlimited. Okay? Any questions on that, either at home or in person? So when do you have to make it up? Until Thursday. Tomorrow. Yes, tomorrow is Thursday. Which is the actual test. Which happens to be the actual test also. And it's funny, I've done this system already for a few years, and I get the people say, well, mister, you should make it due like tonight, like the night before, because, you know, I can't motivate myself to work on this beforehand if you don't make it. And I'm giving you 2 days so you have a little bit of flexibility. Look, please, try to work on this tonight. You're right, you do have a test tomorrow. The whole purpose of this is to get you to study for tomorrow's test. Okay? You might have seen this make a little bit of a dent in your grade, you know, either positive or negative, but tomorrow will make a huge difference in your grade. Tomorrow will make a very, very big difference. The test is going to be worth a lot more. That's the only take once. It'll be curved. It will be curved, but it's going to take once. Any questions there? At home? Yannick, you joined us. Did you hear that, Yannick? All right. So how many times can you make it up, Yannick? Make it up how many times? Once. Very good. Gotcha. All right. So now let's move on then to review. Again, if you're here in person, I gave you a printout of this. There's no notes for this week. This week is there's not even a homework assignment. I don't know if you noticed. This is the only week in the semester that there's a homework assignment. That wasn't necessarily by design. I just didn't have anything else to give you. So this is kind of like your homework is to study for this week. On the weeks that there are notes, I do print them out for you if you're here in person. I'll give them to you. If not, you can have to download them from home. All right. So these are only the ones that were missed the most. I think all of these were like 50%, like more than half of you missed every single one of these. So here's the first one. And sadly, like this wasn't a lot of people, but this is about 3 or 4 people that they actually got the right answer. They marked it wrong. On all the free response on Google Forms, if it asks you to type it in, just type in the number. Don't type in a unit. Don't type in like this is in feet. Don't type in feet. Just type in the number in the Google Form. So find the length of LJ, of segment LJ. So LJ is a little piece of a chord. And if you use our properties, we know that if a radius intersects a chord at 90 degrees, then that, yeah. Oh, sorry. I thought I shared it already. Sorry about that. Give that a heads up. It's all Ferris's fault. All right, let me know if you can see it. Yes, sir. Yes, can you see it? All right, cool. I'd like to put this little thing in me here. Corner. All right, sweet. Okay, so if a radius intersects a chord at 90 degrees, it bisects it. So this LJ is going to be the same thing as GL. Okay, so we know that so far. Now let's go into this information here. They also tell us that KP is equal to PL. So This little distance here is the same as that distance there. Because and that's the distance from the center to two different chords. Let me erase some of this here. Here's a chord, there's a chord. Since this distance from the center to each chord is the same, that means that the chords themselves are the same. So not only is LJ the same as GL, it's also the same as GK, it's also the same as, KH. And since they tell us that GH from G all the way over to H is 36, and that 90 degrees is bisecting it, how much are each of those little pieces? If that entire distance from G to H is 36, how much are each of these little pieces? It's bisecting, bisect, cutting in half. It's well, it would be a fair. Luckily, nobody here can hear it. It's not 12. Yeah. It'd be funnier if you guys could hear it. Because then they won't hear me. It's not so much the hearing part, it's the speaking part and the okay, so, and because it's a Google form and you have to type it in, just type in only the, if you got it wrong because of that, there's about maybe 3 people or whatever, it's one question, the curve, practice test, just don't make that same mistake on the test. Any questions on that? Anybody either person or at home? All right, this might have been missed the most. Maybe it wasn't, because somebody could have guessed this one. Maybe this one wasn't. This is a yes or no question, and it was just, is this tangent, to the circle? And if XY was tangent, right, if they were meeting at this point of tangency, that would have to be 90 degrees. So what would that make it? What do you call a triangle that has a 90-degree angle? A right triangle. And since they give us all those side lengths, how can you test if 3 sides fit a right triangle? It's that theorem by that guy Pythagoras. Thank you, Ferris. It's called Pythagoras theorem. So yes, fine. A squared is equal to B squared is equal to C squared. Making sure. Well, and actually, this is fun. It's maybe a little bit more tricky because see, this 5 is only the distance from here to here. So how can I find the distance from there to there? What do you call what's in blue? It has a name. What type of segment is it? Radius. A radius. You see a radius anywhere else? Yes, there is a radius somewhere else. A 7. So, yeah, so the side lengths are really 7, 10, and then this side length here is 12. So we have to say 7 squared plus 10 squared would have to be equal to 12 squared. This is 49. This is 100. This is 144. There's 149 equal to 144. And I can actually remember doing something just like this on that. I think it was so the answer there would have been. These are the exact same problems you're going to see on the retake. It's the same problems you saw yesterday. It's the same problems that are going to be on the retake. Find the measure of minor arc CA. So how many degrees are there here? All right. What do you call this? What type of segment is that? It is a diameter. Diameter cuts a circle in half. So I know all of this here is 180 degrees. Okay? What do you call this? What's the name of that? What type of angle is it? Let's use words that we've been using for the past month. Inscribe, thank you, Ferris. And how does an inscribed angle relate to the arc that intercepts? Well, yeah, the angle's half. So in order to find the arc, you multiply by 2. So this ends up being here 98 degrees. Those of you here in person can't hear this, but you'll hear it. You'll have to watch the video. Which I'm sure you're going to want to be able to do is watch this video because the answers to the stuff on the practice. So then now, if this part here is 98, how do I find what's left over?
You subtract 98 from 180.
180 minus 98. So give you, and now we'll just multiple choice. Find the measure of angle JKL. JKL. Alright, so what type of angle is JKL? For the second time in 1 minute. Inscribed. So, and I know that an inscribed angle, if I can figure out this arc that it's intercepting, all I would have to do is divide it by 2. Well, again, what type of a segment is LK? It's the diameter. So I know all of this is 180. So if I wanted to then figure out how many degrees there were in this arc that's being eaten by JKL, how can I find that? How can I find how many degrees there are in the arc that's being? Yeah. 180 minus 74. If you subtract those two, that gives you 106. Now that I have 106 degrees, how can I find that angle there? Divide by 2. Divide by 2, thank you, sir. Sam is the man. You know that Sam spelled backwards is Moss? Moss means born. Oh. So in English, you would need a second S. Any questions? All right, keep on going. Find the measure of angle DBC. Should be pretty simple. What type of angle is DBC? This should not have been one of the ones missed the most. What type of angle? There's only 2 types of angles that we really learned about as far as go inside the circle. Thank you, Ferret. Central angle. What is the relationship between a central angle and the arc that it intercepts? You can tell me in one word. What is the relationship between a central angle is made of 2 radii. So that angle is being made by 2 radiuses. So what is the relationship between that angle and the arc that it's eating? In one word. In one word. Congruent. Thank you, Ferret. So the arc is 68. Angel says the angle. Angel has spoken. That question, say something. Maria, anybody questions? Hayden Wright is making an appearance? Oh man. Hayden, I haven't seen you in a while, so I went through this whole spiel about like that we took a practice test yesterday and you can make it up and stuff. But you weren't here, so just make sure that if you do the practice test, you only get points. You only got one shot at it, because I'm basically giving you the answer. I can't keep you guys, those of you that didn't turn in a practice test yesterday, there's no way to keep you to doing it only once, but so the way I keep you to do that is if you turn it in more than once, I'll give you a little bit score. Okay, find the measure of angle C. Again, it should have been one of the easier ones. I don't know how this was missed so much. What type of angle is this?
And on central angle.
Yeah, a central angle. What's the relationship between a central angle and the arc that intercepts?
Congruent.
Congruent. Isn't it just in-person learning better?
Yeah, that's better.
Find the measure of angle ABC. Here I would be I'd be impressed if you guys told me, what the name of the polygon is. Or better yet, the adjective. I'm hoping everybody knows that it's a quadrilateral. Do you guys know what type of quadrilateral it is? No, you're getting too, it's definitely not parallelogram, but, because of the fact it's made up of all chords, it's called, it's an inscribed quadrilateral. If it was made up of all tangents, if it was made up of like of all tangents, it would be called, that was the type one out there, but it would be called a circumscribed quadrilateral, but this is inscribed. And the point is all the angles there are inscribed, so ABC is also inscribed. Who remembers the property that we could use for, because they're not giving us any information about any of the arcs on the outside. So who remembers the property that we learned about inscribed quadrilaterals? It's gonna be on the notes. Ferris, you think you remember? What supplementary? Very good, no, that's a good word, supplementary is a good word, but what's a good word? What is supplementary? Not consecutive angles, opposite angles. Opposite angles are supplementary. So how would I find ABC? This is going back to, I think, like in week 1 or week 2. Opposite angles supplementary. If it's correct. The mistake here is that people think that they're congruent. They're like, oh, they're congruent. No, they're not congruent, they're supplementary. What is that? Is it 103? Yeah. CAB, what type of angle is CAB?
Central angle.
It is not a central angle, it's made up of 2 chords. Lana? What type of, I know you know Ferris, so I'll see Lana knows. No? Ferris is giving you the answer, you can't hear what Ferris is saying. Mohammed, what type of angle is it for the 3rd time today? It is inscribed. So if I could figure out how many degrees are in this arc, I can now come in here by dividing by 2. If we're going outside, it's times 2. If we're coming inside, it's divided by 2. How could I figure out how many degrees there are out there?
Subtract from 180.
From where?
You add these two together and then subtract them from 180.
No! 360, good.
What?
Now, see, the people that are here in class are saying to add these 2 up first, and that's fine, you can do that, you can add them, or you can also just do 360 minus, I just figured it's easier for the calculator, if you have a calculator, 360 minus 122, and then hit minus 108 also. That should give you, come on, 130, yeah, 130. Did Katie ever make it? Is that candidate for Katie? No Katie. Yeah. Oh yeah, you're right, thank you. Look at that. Even I would have got that one, thank you. I got carried away. Yeah, don't write that down, erase it if you just wrote that down. Yeah, this does give you 130, but Muhammad is correct. If I had, anytime you catch a mistake, if I have candy, I'll give you candy. Yeah, this is 130, but I have to divide by 2. He's right. So the angle then will be 65. Remember, I know you want to. I won't come in, so
Get him a lollipop.
Find the measure of minor arc CD. So how many degrees are there from here to here? Alright, well, let's see. If I could figure out how many degrees there are here, then I could go ahead and go times 2 to find out, but I don't know how many degrees there are. Anyway, there's probably there are more than one way to do this. I would probably tell you to focus here. There's more than one way to do this. Well, 2 or 3 ways to do this, but let's focus there, right? What type of angle is that? It is inscribed. What is the relationship between an inscribed angle and the arc it intercepts? No, not inscribed. Central arc. Inscribed. Multiply by 2, thank you, Ferris. So 61 times 2 means that all these degrees from here to here are 122. So if I'm looking for how many degrees there are there, take us home, Sammy. How can I find how many degrees there are left over?
Add 122 and 134.
Why are you saying 180, Ferris? 360. That's why I asked Sam. I wanted to hear Sam say 360.
Yeah.
Get 360 and take away those two. What is that? 156, 256. So that leaves 104. See? Anyway. Yeah, hey, for those of you guys in here, like tomorrow's test, I can't give you a calculator. Like we're not doing all COVID stuff. We can't.
Oh, yeah, no, I gotta say.
A circular fountain has a radius of 1 foot. What is the fountain circumference? So what is the formula for circumference that involves radius? Very good, thank you, Curtis. 2 pi r. And see here, they give you a substitution for pi. So you gotta be careful on these to see if you leave the pi or not. Here they tell you not to leave the pi. So we're gonna just have a substitution party and invite all of our substitution friends. The pi becomes 3.14. The radius is just 1. So 2 times 3.4 times 1 is 6.28. And I would remind you, sadly, that these are only the ones that were missed the most. So that should tell you that we should be pretty simple. Like I said, like basically, this is as hard as it gets. Hopefully you guys do better tomorrow. Ooh, okay, we haven't done one of these yet today. This is not these are angles inside of a circle, but it's not essential, and it's not inscribed. But the fact is that the intersection is on the inside. So, what operation did I tell you to think of when we have an intersection on the inside? This is what we did most recently. Yeah, to add, and it's going to be to add the arcs. So the arcs are x at 162, x plus 162. Always over 2 is equal to the angle, which is 118. Times 2, times 2. X plus 162 is 236 minus 162. 74 degrees. This was fill in the blank, so what would you have typed in on the Google form? Just 74. If I'm doing mental math wrong and you have a calculator, let me know. Any other questions there? Alright, we look like we should have plenty of time to finish. Okay, where's the intersection happening here? We have a secant, and we have a tangent, it looks like. But where's the intersection happening? Angel? ¿Dónde está el intersection? I'm only asking Angel. His friends call him Jude. What? It is on the outside. What operation did I ask you to remember when it's on the outside? Subtract. So when you subtract, we want the bigger arc, which is like the further outside of the mouth. The small, so we're going to go big. Let's do it 94 minus x, always over 2 is equal to the whatever the angle is, and that angle is 28. 2, cancel, 94 minus x is equal to 86. 94 minus 94. Negative x is equal to negative 38. Alright, some of you already know that it's gonna end up being 38, but if you wanna know why, you can show it to all your friends because you multiply both sides by negative 1. All that does is change this to the minus 38. What would you type into the Google form? Just 38.
Is that 5?
5, what do you see 5?
Again, S.
S. 56?
Yeah.
What do you mean? You see S is because that's when the first letter is in.
And
You see S is everywhere. Very good. This practice test was scored based out of 29 points. Your average was based on 29. There was 29 total individual. Like there was that one question that had all like the labeling stuff, and that was five of the 29, but it was still 29 points. I'm giving you 19 of them. I am giving you the answers to 19 out of 29 questions. So that's all for you. Okay, where's this intersection happening? It is on the outside. What's the big arc gonna be here? X, good. The minus is on the outside. What's the little arc? What's the furthest down the middle? 63 is divided by 2 is equal to 43. Times 2 times 2 times minus 63 is equal to 86. Plus 63 times 149. Let's type in the 149. Okay? 4 more. A tangent meets and I believe that this had a preface on it that said something like tangent. Those segments that appear to be tangent are tangent. So when a tangent meets up with a radius at a point of tangency, what type of angle is created? Second time we saw this today, we did one on like a right triangle. Back then we were asking if it was tangent, not now they're telling you it's tangent. It's 90 degrees. So if these are taking up 90 and 90, what's 90 plus 90? 180. So then how many degrees are there left for these two to share? How many degrees are there in a quadrilateral? 360. So there's 360 in total, but 180 of them are being used up already. How many degrees are left?
108.
180, and no, I'm not asking for X yet. I'm just saying that in red, if I'm taking up 180 degrees out of the red, how many degrees are left of those two other angles to share? 180. There's a name for that. It's called being supplementary. So then the X is just going to be equal to that, the 180 degrees you have left, minus the 71 that's being used out there.
109.
That's what you would type in. Don't type in X equals also into the Google form. Don't type in an X equals, just type in a number. And I thought I had put a restriction that wouldn't even allow you to answer it. I don't know, maybe on some of them, some people snuck by and started putting like units and stuff. Just put the number. It's the only way to guarantee that you will get it right. Assume that lines that appear to be tangent are tangent. Alright, so that's the case. This is a tangent intersecting with a radius at the point of tangency. This is 90 degrees. How many degrees are there in a triangle?
180.
There are 180. So then how many? If there's 180 degrees in total, and I'm already using up 90 here, how many degrees do I have left for those two to share? 180 degrees total. I'm using up 90 of them. How many are left over? 90. 90 degrees left over for these two. Okay? Now, here's where you can really show me that you learned something from first semester. There's a word for that too. What is the word for, angles that add up to 90 degrees? You probably live the rest of your life without knowing this, and you'll be just fine. It's not supplementary. Angel, you want to guess? Muhammad, no guess?
I'll give it a go.
So we're gonna say, huh?
From your angle?
One word. Not supplementary. It kind of sounds like it. Complementary, good. Good, so, I can say X is 90 minus 28. Where were you on that one, Ferris? You guys have pain ears and stuff when wearing the mask.
No. I'm getting some of my ears.
I have this other mask but I'm more comfortable, but this one gets more than my ears. Yeah, well, Miranda already said comfortable. And if you have questions, say something. Yannick, I haven't heard from you today. Ooh, this was a good one. So Peter wanted to know the perimeter, right? And this goes back to the first week. Okay? When you have tangents, these are all tangents. Okay, if you want to be more fancy, you heard me say a word earlier. If you have some type of a polygon that's made up of all tangents, that tangent is circumscribed. Again, I feel like I remember Muhammad asking me a question about what that word meant, circumscribed. Okay, so that means it's not circumcised, but circumscribed. And if those tangents meet at a common exterior point, what property did we learn? If those tangents meet at common exterior points, what property did we learn back in week 1? The distance from that point to each point of tangency is congruent. So this is the same as this. This is the same as this. This is the same as this. This is the first one. So that means that this would also be 8. This would also be 16. This would also be 11. So what's the perimeter there? Add them up, right? What is that? 16, 16 to 16 is 48. And so is it 60? I'm getting 60 in my head. It would be 60 inches, but what would you put into the Google form?
70.
Is it 70? Did I count wrong?
7.
Oh, it's 22. You're right. 70. Thanks, Sam. What would you put into the Google form? Put it to 70. Let's put that into the Hayden, I thought you had a calculator. Sam has a calculator, and it's faster than yours. Alright, last one for the day. Here, see if you guys can do this one on your own. Same exact type of thing, only this is a quadrilateral. What are you subtracting first? Yeah. We're asking for the perimeter. Alright, Sam got 45.6. Let's see if Sam is right. So the distance from each point on the outside to the back of the point of tangency is congruent, so 8.3, 8.3, 5.6, 5.6, 4.1, 4.1, 7.6, 7.6. So I know that this is, these two together are 15.2, these two together are 16.6, these two together are 9.2, these two together are 8.2. So 15 and 8 is 23, 39, 50, 51, 51.2 is that what you got?
No,
You got 45.
I'll check again.
Okay, I'm gonna use my calculator too, but maybe my mental math is off. Let's see. 8.3 plus 8.3 plus
5.6 plus 5.6 plus 4.1 plus 4.1 plus 7.6 plus 7.6. I got 51.2, so I got my
Yeah, I missed that.
51.
Alright, so, again, if you check your school email, you will see what you entered originally on these. Okay, it won't tell you the right answer, but I've given you the right answer now on 19 out of 20 out of these. And have until tomorrow night to do it. Tomorrow, if you didn't notice from yesterday, the bell to release from first period is at 8:10. The quicker you get here, the quicker you can get started. Okay, like you get here at 8:12, bam, log in, get started, so you have more time. You gotta bring your own materials if you're coming in person. I will post the test code on eClass again, and then tomorrow's just one shot. So, after tomorrow, I will also send out the first project report of the year to you folks. Any questions for me? All right, those of you that are online, you are dismissed. Those of you that are in person, just hang out until the bell rings.